Sockets for the CPUs installed, along with the crystal and the capacitors. Timing circuit for each one. Each one uses a 16 megahertz clock. Here we have the socket installed for the 74 AC14, which will be our Schmitt trigger. And installation went very smoothly on those, so we'll continue on. Right now we've got all the resistors, the diodes, except for the LEDs, are installed, and our off-board headers on the end of the board. So we're coming along, making progress. We'll do the capacitors and the LEDs, the reset switch, and then we'll get into the onboard headers. All the components are mounted except for the plug-ins. We've got some sockets to go yet. We just did the socket for the keyboard. We'll add some more sockets and we'll be pretty close to programming the CPUs, plugging them in and giving her a shot. Time to stuff in the ICs and see if we can program the CPUs. Then we'll finish putting it all together. Both CPUs are installed, and the 74 AC14 is installed for the Schmitt trigger, although that won't be activated yet until we put the GPS module in there. Then we have to add the keyboard and the display up here, but we'll go check the CPUs out first, make sure we can program them. Everything's working okay there. So far so good. Plug the programming ports into the computer, and the CPUs take off their pre-program where it's flashing hello in Morse code. Those are the red flashers. Da-da-da-da-da-da-da-da-da-da. That's why I tested them out when I bought them and put them away to wait for later use. I programmed hello on them, and there it is. So they're working. Now we'll see if we can program them and just put in the simple Arduino Blink program. See how that goes. Then all will be fine. We'll put in our master and CPU program for the frequency standard generator and move on with the rest of the assembly. There we go. We just programmed both CPUs, the master and the slave, with the simple Arduino Blink sketch, and downloaded, compiled okay, downloaded okay, and programmed them, and there they go. They're both just doing simply a blink now, no Morse code flashing anymore. So all of that works. CPUs are working. We can load our sketches to it. So we're going to go ahead and download the master and the slave CPU program, or sketches, on each of the CPUs, and we'll see how that looks, and we'll finish the construction. Everything is plugged in now. It appears to be working fine, like it was designed. Here are the two programming FTDI interfaces. We'll take those out, but we'll leave them in for the time being while we play with the program a little bit. There's our readout. It's working fine. We got our generating 5 hertz right now, and the battery voltage says it's 4.37. We're not really running with the battery, so that's pretty good. We have 8 satellites. We're locked into 8 satellites right now. I don't know if that's some kind of a record or what, but it's doing very well. And over here we've got our keyboard installed. Here's a little GPS unit. That's all there is to it. We still have to solder in our SMA connector down here for the output, and we'll get at that after we button the rest of this stuff up. CPU 1, CPU 2, both performing flawlessly. So I think we're about there. Notice we've added some headers here to be able to, in an emergency or whatever, just for fun, to save a little time, we can program the Arduinos without having to take the readout out of its socket. It depends on how we mount it. Right now I've got a cable plugged into the readout, because the original sockets you can't put the readout in while the sockets are on, can't plug it in. So this way I can test it, then I'll plug the readout in. But then, if I want to play with it some more, I've got these handy little headers coming out. I also added a GPS output here, so I can hook a 9600 baud TTY on there, TTY program on a computer, and monitor what's actually coming in on the GPS, because the program filters it all out except for the information that it needs, which is the number of satellites and whether or not it's locked or not. Otherwise, it just accepts info from the main CPU, the master, to tell it what frequency to generate, and it reports back information on the number of satellites and the lock status. This is the power LED, tells us whenever power is applied. Machine is finished. Hooked up our SMA connector. I put a little cover on the power on LED to cut down on the brightness there to make this video. But she's working according to spec. Right now we're generating a 10 kilohertz signal. And you can see on the scope here, we'll show you close up on the scope a little later. Got some overshoot going on there. We'll talk about that later. I just hit auto on the scope to line her up again. There we go. Now, I'm going to reset the unit by hitting the reset key right here. And you can hear what happens when we start up. The University of Nebraska fight song. There is no place like Nebraska. Okay. She's working. We start her out with a 10 megahertz display. It's a 10 megahertz standard. You can see we really took off on our screen there. We'll hit the auto check again on the oscilloscope. There we go. We'll talk about that waveform a little later. She's a bit jittery. You can see the ringing on the top especially. But that won't bother us since we're looking for a 10 megahertz signal, and there it is. And without any further ado, we'll do one more entry. We hit the asterisk key to enter a frequency. You can see it says enter the new value. We'll do 100,000. New value is 100,000 and 100K. We hit the pound sign key to do the entry, and we've sent that now to the GPS. The GPS is transmitting a signal of 100K. And again, if we go back to the oscilloscope and do our magic auto set, I love that feature on these newer scopes. There we go, right on the button. And we're currently receiving 4 or 5 satellites all the time. There's 4 and we're locked. The L means we're locked at 100 kilohertz. And our battery voltage is 8.27 volts. Got a little loss going through our diodes there, but that's not hurting us. Power supply is set at about 9 volts, 9.04. Sucking a very low current. So all is fine. All is working well. I'll get some close-up pics on the scope. Checking our output signal on the scope. Here we have a 10 megahertz signal. It has a little jitter on it because that GPS runs on a 48 megahertz crystal, and dividing down to 10 megahertz isn't exactly kosher. We get a little flutter on the signal, but she's 10 megahertz, and we're locked to 7 satellites right now, so we're locked to the satellite atomic clocks. So we're doing well. We're right in the ballgame. Now there's some ringing on that signal, significant ringing, but that's how it is. The main purpose of this thing is for the frequency. We want to use it to adjust frequency on our equipment and our radios. So there's the 10 megahertz signal. Let's take half of that. We'll do a 5, 2, 3. We'll do a 5, 1, 2, 3, 1, 2, 3 megahertz. Enter. And we're still have the ringing, but you can see it's the pulse is lasting a little longer than the ringing now, so we see it ring as it comes up and then die down, and then bam, goes to the bottom, overshoots a little bit, rings some, and back to baseline. But she's right on the button there at 5 megahertz. So let's go down to 10 kilohertz. I use a 5 to 10 kilohertz a lot if I'm working on audio gear. Let's go to asterisk and enter 10. 1, 2, 3. Just hit the enter key. Move the signal down here to the middle of the screen. So we got a pretty good square wave. 10 kilohertz. Pretty much on the button. You can still see that overshooting the ringing there a little bit. But that looks pretty good.